Okay, hello everyone. So now let's look at our day three. So day three, I will talk about very important things about the quadratic roots. So maybe this is just a kind of secondary school knowledge point, but sometimes it's very useful. We can use this method to solve some complicated geometry question. Okay, so yeah, why I can use that? Because sometimes once you know about the Pythagorean theorem and also you have something like the isosceles triangle, you can draw a height. And actually, you can just calculate this height, right? But when you do the calculation, you will meet a lot of problem, right? So if you don't want to prove the geometry, maybe this is a good way for you to calculate the answer. It's a very useful thing. You can change a geometry question into an algebra question. Okay, so before we look at that, so we need to know something about the numbers. Yeah, it's very important. So actually, math is a subject with the numbers. When you go to kindergarten, your teacher will tell you some numbers, right? So at the first time you learn math, we always start from the numbers, like the 1 plus 1 equals to 2, like that. So actually, yes, when we talk about the numbers, we have a very important thing. So first number, we may think all the things is about 1, 2, 3, 4, and blah, 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 blah. So actually, they tell you, okay, so these are the integers. Maybe when you are only P1 or P2, you just maybe think, okay, so is it we only have the 1, 2, 3, 4, and continue about the integers, right? Actually, no. Yes, actually, the teacher will tell you, so this part is about, we call it natural numbers. Okay, we call it natural numbers. And now, after that, you may think it's about a zero. Okay, so what is zero? Zero is outside the natural numbers, and we put zero here. And all the 0, 1, 2, 3, blah, 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 continue. So we call this one whole numbers. We call this one whole numbers. But once you learn a lot of math and you suddenly find, okay, so, but how about some interesting things? So maybe we have what? We have the negative numbers. So you learn something about the number line. Here is the 0 point. On the right of the number line, they are all positive numbers. And on the left of the number line, so all is the negative numbers. Negative numbers. So maybe I will have something like the -5, -2, -1, and so on, right? So we call this part all the things. We name it integers. Okay, we name it integers. So this is about the integers. But what else? What else? So when you go to the P3, your teacher will tell you, okay, so I give you a pizza. So you think a pizza is just like a 1, and maybe you want to cut it into 60 pieces and separate to all the children's. Then each part is just 1 over 16. So this 1 over 16, and maybe something, for example, maybe 1 over 4 or 0.25. We name this one is a kind of what? It's a kind of fraction. We call this is a kind of fraction. Okay, so we know this fraction and all the integers. We name this one is a kind of what? It's a kind of rational numbers. Wait, we name it rational numbers. So actually, to remember this concept of rational numbers, we can simply remember this word. The rational numbers means all the fractions and integers. All the fractions and integers. But what else? What else? So you may find a very interesting. So we have already know this about the rational numbers. When you go to P5, your teacher will tell you, okay, so there is a chapter how to calculate the area of the circle. So when we talk about a circle, your teacher will tell you, okay, there is something about pi. There is something about pi. So what is pi? Is pi a kind of fraction or integer? Obviously not, right? Obviously not. So we call this pi is a kind of what? It's a kind of irrational number. Okay, we name it a rational number. A rational number. And after that, so also we have some root numbers like the root 2 or root 3, and we cannot write it into the fraction form or the integer form, so we just name it as the kind of a rational number. So now in math, we call the whole things is a kind of real numbers. They're just the real numbers. Okay, so this is the classification of the numbers. So maybe some of you may ask, okay, teacher, I have the real numbers. Maybe do we have the fake numbers? Do we have the fake numbers? Yes, we have. But actually, we don't name it fake numbers. We call them what? We call them imaginary numbers. Okay, like the imaginary numbers. But you won't learn imaginary numbers in your secondary school, maybe just in JC or the university. The teacher will tell you. So what is the imaginary numbers? You can easily think. So the rule, if you know the rule of the root, you'll easily know that. Okay, so let's talk about what is root. So what is the things about the quadratic roots? So that I think you have already know in math, we have Pythagoras theorem. The rule is like here. If I have a right angle triangle, so this side is A, this side is B, and this side is C. So we have the rule A squared plus B squared equals to C squared. Then sometimes we have the 3 squared plus 4 squared equals to 5 squared. So that means if a triangle which three sides is 3, 4, and 5, we can make sure this one must be a kind of right angle triangle. But not always the number is still beautiful, right? So maybe we have a kind of triangle like that. Okay, so this one is 2, this one is 3. So how about the hypotenuse? So you want to use this formula to do the calculation. It will become 2 squared plus 3 squared equals to 4 plus 9 equals to 13. But 13 is the question mark's square. So how to represent the question mark? Now we have the root. So we have the question mark equals to root 13. So actually the root in one word is like you need to find out the number times itself, become the number under this root. Right? So this is the definition. This is the definition. Like what? Like we know 6 squared equals to 36, then root 36 equals to 6. Okay? Like that. So about root, we have a kind of things very important. For example, root A. Okay, root A. So this actually means A should be bigger than 0, bigger or equals to 0. And also the root A also should be bigger or equals to 0. Then someone may ask, okay, so teacher, how about a negative number? So is it very easy for us to find out a negative number who times itself can be a negative number? Obviously not, right? So we cannot find it. So actually, this is the definition of the imaginary number. So if the number under this root is a kind of negative number, like -1, so we call this one is a kind of imaginary number. So, but you won't use that, okay? You won't use that, you just know about that, it's okay. So this is the principle of the root. But so once you see a root, you should know in primary school and secondary school, the 6 must be a non-negative number. What else? But if I'm asking what is the square root of, for example, 36? So that means this number times itself becomes 36. Then actually we have two answers. One is positive 6 and the other is negative 6. Or you can just write it into positive or negative 6. It's like that. Right? So this is a very useful thing. We can just use this method to calculate some harder geometry question. Maybe we have the right angle, we can just use that. Okay, as I show you guys in the sample paper. That question, I just used the root method to do the calculation. So how to use that? So I will introduce some basic rule of the root. Hey, so the first thing is about root a times root a. So because we know root a means the number itself times itself will become a. So root a times root a, of course, equals to a. And root a times root b. This one equals to root a times b. Root a times root b equals to root a times b. And for example, how about this one? Yeah, root 2 times root 10. How to calculate that? So we can find this one actually is root 20. But we won't always write down this root 20 as our result. Why? Because we can find root 20. Actually, we can do the simplify, right? So we can write down this one. Actually, it's root 4 times 5. And I can separate into root 4 times root 5. So it will become 2 root 5. It will become 2 root 5. Okay. Also, we have an example. So for how about root 32? You know, 32 is what? It's 2 to the power of 5. So actually, I can just write down like the 2 times 2 to the power of 4. This will become just the 4 root 2. It will become 4 root 2. Hey, so this is about the basic rule. Now, we have another very important thing about the fraction. How about the fraction? About the fraction, we will have another rule. Okay, so for example, if I have the root a over root b, I can rewrite it into root a over b. But we will not always write in this form. We will just keep, the rule is we need to keep the denominator as a rational number. So we call this method rationalize. Okay, so for example, if I have like this part, root 7 over root 11. This actually is what? Root 7 over 11. But of course, this is not, the denominator is not a kind of rational number. So I can do what? Remember, for the fraction, on numerator and denominator, we can times the same value. And the fraction itself, the value won't change. So it will become root 7. If I want to make sure the denominator will become a rational number, so of course, I can just times root 11. So I times root 11. It will become root 77 over 11. Okay? 77 is 7 times 11. Of course, we cannot do a simplify. So this is the rule. Okay, so this is the rule. So yeah, this is the first things. And when you do the calculation, we have a very important things. It's about the conjugate root. So this is another way we can do the simplify. For example, if I have what? If I have something like I just show you the example, 1 over root 3 minus 1. So how can I make the denominator become a rational number? So yeah, you need to think about this is like the a minus b, right? So I want to cancel this root 3. I also want to cancel, I only want to cancel this root 3. So root 3 times what? On the previous one, root 11, I just times root 11. So maybe this root 3, we want this one become root 3 times root 3 equals to 3. So what kind of formula we can make this root 3 into like 3, or maybe make this a become a squared? You may think about the difference between two square numbers. We have a minus b times a plus b equals to a squared minus b squared. So you can see this part, I have a minus b, and then I change it into a squared and b squared. So that means once we have a root number, we can just have change it times itself. It will become an integer, right? It will become an integer. So now let's do it. For this one, yeah, root 3 minus 1. So I can just times 1. This is a minus b. So that means I need to times a plus b. So a equals to root 3, b equals to 1. So I need to times what? I need to times root 3 plus 1. And on the numerator, we also need to times root 3 plus 1. So after that, this one, root 3 minus 1 times root 3 plus 1, it will become root 3 squared, 3, minus 1 squared, 1. And on numerator, it should become root 3 plus 1. So this will become root 3 plus 1 over 2. Okay? So this is all the things about our rationalize. So yeah, this is all the things about the quadratic root, and maybe you can do some practice. So I will put in the following. I will also give you the paper. I only give you 3 very easy questions about the calculation. I hope you can master this method. And also I will give you an example for you try to calculate the geometry by using these quadratic roots. Okay.